Welcome to this video created in partnership with Grey Matter on the Intel Oneapi-cli heterogeneity. My name is Stephen Blair-Chappell from Bayncore, an Intel Oneapi-cli technology partner that provides training, consultancy and technical support in HPC and AI. This is the second of 8 videos. In the first video we saw that Oneapi-cli is a programming model for building and optimizing code across different architectures such as CPUs, GPUs and FPGAs and AI accelerators, that is heterogeneity. At the bottom of the Oneapi-cli software stack is the Oneapi-cli Level 0 API, which provides direct-to-metal interfaces that can offload code to accelerated devices. The Level 0 API includes functions for device discovery, memory allocation, synchronization primitives and other low-level elements. Most programmers will not use this API but rather rely on the compilers, libraries or frameworks. 3 things need to be accounted for when writing Oneapi-cli code: offloading the code to the device, transferring of data to and from the device, and implementing parallelism on the device. Here's an example of a DPC++ Hello World program. The code uses regular C++ with Oneapi-cli constructs being accessible from the SYCL namespace. The offloading the code to a device is achieved by submitting the lambda function to a queue. The content of the lambda function will run on the accelerator. In our example, the transfer of data is handled through the explicit use of the buffer mechanism. There are alternative methods available to handle the data transfer that use a shared pointer mechanism rather than using buffers, but we don't show that alternate method here. The parallelism on the device is achieved using the parallel4 construct. Here's an example using OpenMP. The code uses standard OpenMP directives and regular C code. The same mechanism is also available for Fortran code. The offloading the code to a device is achieved using the Pragma OMP target directive. The content of the for loop will run on the accelerator. The transfer of data is handled by the use of the map construct. The parallelism on the device is handled with the parallel4 statement. In this example, the team construct creates multiple threads on the device. Loop iterations are spread out amongst a team of threads using the distribute construct. You can experiment with different programming examples using the Oneapi-cli command line interface. Here's a DPC++ example of a matrix multiply. And here's the code for the OpenMP solution. And then this third example is using Oneapi-cli. In the next video, we'll be looking at the Intel Oneapi-cli toolkits.